Alright, so to do this one, remember we're doing the chain rule. So I find it easier talking about y's, so I'm just going to change this to y equals x cubed minus 3 to the power of 5. Okay? And then all I'm going to do, because it's a composite, it's a function within this function. Okay, so I'm going to say let u equal x cubed minus 3. So therefore I've got y equals u to the power of 5. I've got my function within a function. Okay, and all I have to do now, by the chain rule, to find out what dy by dx is find out what dy by du is, and then multiply that by du by dx. Okay? That should be a u. Du. So, dy by du, that should be not hard at all. 5u to the power of 4. Du by dx, again, that's not very hard. That's just 3x squared. So now, dy by dx is simply that times that. Okay, is that my answer? Because I'm differentiating y with respect to x, I've got to have all x's in there, unless it's a parametric function, which we'll get to later on. So I said I said u was this. So that's 5 lots of x cubed minus 3 to the power of 4 times 3x squared. Okay? There's my answer.
Would you simplify that to 15x squared?
15x squared, x cubed minus 3 to the power of 4 is my simplified answer. That's probably the better answer of the ones, but yeah. Are we happy with that? Does that seem pretty easy, to be fair?
Yeah. Why would you ever do that way if you did that?
The way I said before, which I didn't put on the video. Yeah. So I wouldn't, because I know the chain rule. This is me trying to teach you the chain rule. Okay. So in other words, what I would do in this box, and probably what some of you might have done, it's gone f dash x is going to be 5x cubed minus 3 to the power of 4 times 3x squared. Now differentiate the function, multiply by the derivative of the bracket. That's what you're doing, which gives you the same answer, but obviously 2 lines of work and 1 line of work. Happy with that? All right. This one here is next to. To do this one here, what do we have to do? So put the bottom line in brackets, boom, like that. To the power of negative 1. So gx equals 2 5x plus x to the power of 4, all to the power of negative 1. Okay, it's different to the ones yesterday because that was just 1 over x. This is everything in the bracket becomes the power of negative 1. Now what are we going to do? Differentiate it. 2 times negative 1, 5x plus x to the power of 4 to the power of negative 2 times by 5 plus 3, rub out, 4x to the power of 3. Oh, that's where it gets a little bit trickier doing it that way. Who followed that? So far less followed it. Who followed it before? Who followed that before? Probably the same way, to be fair. So. Okay, so this one here, that's my answer, by the way. I can just leave it as that. Okay, I can tidy up and make it two lots of 5 plus 4x cubed all over, so that should be negative 2. 5x plus x to the power of 4 squared. I could do that. Okay. I'll do the last one. I'll do the last one, and I'll do the last one back. Let u equal that. Are you happy? So y therefore is the square root of u, which is u to the power of a half. Is that right? So now we've got dy by du equals a half u to the negative a half. Happy? Du by dx is 3x squared. Happy? So therefore dy by dx, which is du times du by dx, is 1 over 2 u to the negative a half times 3x squared, which is 1 over 2 times x cubed minus 2 to the power of negative a half times 3x squared. Okay. Now I'm not going to stand here and say that looks easy. I'm not going to stand here and say that answer is nice and tidy. But I'm going to say once you get the hang of it, the process about it, the chain rule, I reckon we can all do and find that nice and easy. Happy with that? Any questions? No?